Today we are going to be discussing weather fronts. So the main idea is that a front is where two different air masses meet, and it's usually a warm or cold air mass meets, or multiple air masses meet. So this is the jet stream here, and the jet stream generally, well, the polar jet stream, the jet stream generally separates warm air in the south from cold air in the north. But it bends and it meanders and it changes its shape. But where this cold air reaches the warm air, or where the warm air reaches the cold air, that's usually when we have our weather or our rain. Okay? So whenever we're just like stuck in a cold air mass or stuck in a warm air mass, those are usually our calm weather days. And wherever there's a transition or a change, that's when we receive different weather. So you'll notice in the summer, during thunderstorms or before thunderstorms, it'll be really, really hot and uncomfortable. And then right after a thunderstorm, usually it'll be the air will be a little drier and a little cooler. So that is the air changing from warm to cold, meaning that a cold front came through. The cold air pretty much came in and pushed the warm air away. Similar to that, like in the winter, you'll notice that before it snows, it'll actually be pretty cold, like colder. And then after it snows, it'll be warmer. And all that's happening there is that warm air is coming in and pushing cold air out of the way. Kind of how it works. But the idea is that whenever we have a major temperature change happening quickly, that's usually when we receive some type of rain. Okay? So let's skip through this and let's get to the fronts. So, here's the main idea. You may have heard the terms warm front or cold front. There's also occluded front and stationary fronts. Main idea is that whatever the front is named, that is the thing that is pushing in. Okay, so if it's a cold front, it's cold air pushing in because it's the front of the cold air that's moving forward. Same thing with a warm front. If it's called a warm front, that means warm air is pushing in to the area. Okay, so let's look at some examples of that. So in this case, if we have this diagram set up, right, this is going to be the symbol for warm fronts. It's usually in red, and it's usually these hemicircles or these half circles. And these half circles point in the direction that the air is moving. So in this case, we have a line that separates the warm air from the cold air, and we're showing that the warm air is moving towards the cold air. These types of storms are usually the storms that last for like 12 hours to 48 hours. So it's just like those days where it rains all day, or those days where it snows all day. These are usually our warm fronts, okay? So this is really what's happening. At the surface of the earth, we have this warm air rising up and over this cold air, okay? It usually creates a gradual slope, not a steep slope, for warm fronts. And that's just because the warm air just kind of like plops over the cold air. So you'll see that the air is then forced to rise up and over the cold air. The warm, moist air is forced to rise up and over the cold air. And if you remember, clouds form due to warm, moist air rising, expanding, and cooling. That's how a cloud forms. So clouds form due to rising, expanding, and cooling, which causes clouds and then rain, or clouds and then snow, or whatever weather is actually happening. And since it's a warm front, it's the warm air moving towards the cold air, so it pushes it. All right? It pushes it. Now there's the cold front. The cold front is a little more aggressive. So cold air moves in like, if you've ever like done this with a blanket where like it like rolls through, it moves quick through, and it creates this steep slope down near the Earth's surface. Again, it's a cold front, so cold air is moving towards this warm air. And it's taking this warm air that's sitting here. Eventually, it'll slowly move, right? It'll move this way. Sometimes really fast. Sometimes these storms move like 60 miles per hour. And that's when we get this extreme weather. And it forces this warm air to rise really, really quickly. When we force warm air to rise quickly, it cools very quickly. And when air rises, expands, and cools, it forms a cloud. And the faster it does that, the more intense the cloud forms. That's how we get these big, big, tall clouds. You live in an experience in the summer. This is a thunderstorm. So a thunderstorm, it'll be the middle of the day, and it'll be like dark out. And that's because this cloud forms so quickly and rises so fast that it expands and cools and reaches its dew point, causing insane amount of rain at one time. All like within 15 minutes. Sometimes this can cause air to rise and expand so quickly that it goes so high in the atmosphere that it freezes and causes hail. Okay? But the main idea is that a warm front is a shallow slope or a gradual slope where we have warm air rising over cold air. And the warm air is moving towards the cold air. And the cold air is even kind of like running away from it. When we have a cold front, it is cold air moving towards warm air, and it has a steep slope there. That steep slope causes that extremely quick and intense rain or thunderstorms. All right, and you can see the cold air moves towards the warm air, just like that. So that's really what's happening. Cold air is moving towards the warm air. All right. So this is how this usually works. This warm air is going to be going towards the northeast because low pressure systems and almost all storm systems for New York track towards the northeast, or they move towards the northeast. So the warm, moist air from the Gulf of Mexico is going to be moving up, right? So you can see that this takes like a day or two. It rises up, while cold air that has swooped down from Canada now moves with it. So what we usually have here is, since it's a low pressure, we usually have rain. There's usually a lot of rain in front of the warm front because at this point is where it starts to rise, expand, and cool. But the cold front, since it's a wall of cold, usually has a really, really thin storm across it, which is usually some type of thunderstorm, especially in the summer. Okay? So, one more thing is that sometimes cold air, as it's going towards warm air, it'll reach another pocket of cold air. And that causes it to wedge like this. The cold air reaches the other cold air and it wedges the warm air up. And this is again how we receive just like a day where it's like just cloudy all day, or a day where we have a little bit of rain on and off, or light rain all day. That would be like an occluded front, okay? And a stationary front is just going to be where the cold air and the warm air aren't moving towards or away from each other. They're just sliding past one another. So let's review. Warm front. Warm front is a gradual slope where warm air is moving towards cold air. And this creates storms that last maybe a day or two. A cold front is where we have cold air moving towards warm air. It creates this steep boundary between the cold air and the warm air, causing the warm air to rise, expand, and cool super fast, causing a 15-20 minute storm, like a thunderstorm. Okay? An occluded front is where cold air, and with some warm air between, and then some other cold air, where the cold air reaches the other cold air. And that causes the warm air to wedge up and creates just like cloudy days, like I said, or light rain for an extended period of time. And then a stationary front is just when the cold air and the warm air are not moving past each other. This is stationary. You can see the symbol. It's like, the warm air is not moving towards the cold air, and the warm air is not moving towards the cold air. Cold air is not moving towards the warm air. They're just sliding past one another. Okay? All right. So let me just go to the reference table and show you where those symbols are. If you need to know what these symbols are, you'll see at the bottom of page 13. Bottom of page 13 with the weather map symbols. Here are the front symbols. So cold front is the triangles. Warm front are the half circles. A stationary front, where the air is sliding back and forth past one another, is where we have the every other side is a triangle and a circle. And occluded has every other, but all on the same side. All right? Hopefully that makes sense.